Hello dear students, let's start a new topic. Mole concept. Mole concept from chapter 5 of class 10th in subject chemistry. Let's open your chemistry book and come on the page number 85. What is the mole concept? So as you know that atom is a very small particle, minute particle, and to find the mass of a particular atom is very difficult. Let's suppose you have some apples, and one apple have the mass is 200 grams. Then in 1 kg you can find that how much weight, how much number of the apple present in 1 kg of the apple. Let's try to understand. Suppose 1 dozen is equal to 12. 1 gross is equal to 144 objects. Suppose the 1 dozen of apple in 1 kg, it means that in 1 kg there are 12 apples present. In 1 kg, if there are 6 mangoes, then you can say that in 1 kg half a dozen of the mango present, because apple and mango have the bigger size and we can easily observe by our naked eye. But atom is very difficult to observe by our naked eye because it is a minute particle. So it is very difficult to say that in 1 gram of the atom how much number of atoms present in 1 gram of, suppose that carbon atom, in hydrogen atom, in oxygen. Then if 1 gram of hydrogens, then how many number of the hydrogen atom present in 1 gram. So by relating the terms of the numbers and the weight of a particular atom or molecule or ions, we can apply the mole concept. Now, what is a mole concept? In 1 mole of atoms, in 1 mole of the molecules, or in 1 mole of the ions, our scientists find that a collection of 6.023 into 10 to the power 23 particles present in a mole, 1 mole. That means 1 mole of atom presents 6.023 into 10 to the power 23 number of atoms, or 1 mole of molecule means 6.023 into 10 to the power 23 number of molecules. So how can we define the mole? A mole is defined as the amount of a substance containing elementary particle like atoms, molecules or ions equal to the Avogadro's number, and the value of Avogadro number is 6.023 into 10 to the power 23. So mole, the amount of a substance which contains, the amount of a particular substance which contains 6.023 into 10 to the power 23 numbers of atoms or molecules or ions, whatever. So what is the Avogadro's number? Avogadro's number is defined as the number of atoms present in 12 gram of carbon 12 isotopes. So Avogadro's number is the total number of atoms present in 12 gram of carbon 12 isotopes. If you have the idea of the atomic weight of one atom, then you can easily find that how many number of atoms present in 12 gram. Again, if you have the idea the atomic mass or weight of one atom of carbon, then you can easily find that how many number of atoms of carbon present in 12 gram of carbon 12 isotopes. And it was found by a scientist Avogadro's, and that value is 6.023 into 10 to the power 23 atoms, and that number is called the Avogadro number. Now the Avogadro number 6.023 into 10 to the power 23 is equal to, in case of a atom, equal to the number of atom present in 1 gram atom of any substance, is equal to number of molecule present in 1 gram molecule of any substance, is equal to the number of ions present in 1 gram ions of any ionic substance. So let's go through the examples. Now first let's see, so what is the mole? Mole equal to weight of atom. Suppose mole of atom equal to weight of atom divided by atomic weight of atom of X, suppose X atom, then the mole equal to weight of atom of X divided by atomic weight of X atom, atomic weight of X atom. Let's suppose the how many number of moles present in the 6 gram of carbon. How many number of atom present in 6 gram of carbon? How many number of moles? How many number of moles? So a mole of carbon atom equal to their weight in gram, that is 6 gram, divided by their atomic weight of carbon is equal to 2, so 0.5. So 0.5 number of moles present in 6 gram of the carbons. If we consider in the 12 gram, then 12 divided by 12 equal to 1 mole. So 12 gram is also called the gram atomic weight of carbon. So the mole of atom is equal to 1 mole of atom contains 6.023 in 10 to the power 23. Let's see at the example. So 1 mole equal to 6.023 into 10 to the power 23. Number of atoms of a particular element is equal to 6.023 into 10 to the power 23 number of molecule of a particular molecules, and is also equal to 6.023 into 10 to the power 23 number of ions, and is equal to 22.4 liter. 22.4 liters. So 1 mole equal to 6.023 into 10 to the power 23 number of atoms of a particular. Suppose you can take any carbon, then carbon atom. 6.023 into 10 to the power 23 number of molecules. Suppose a oxygen molecule in their gram molecular weight, 1 gram molecular weight, and equal to 22.4 liters in their volumes. So, as for example, the atomic mass of oxygen is 16 gram. So, the 1 mole of oxygen atom contains 6.023 into 10 to the power 23 atoms of oxygen and has a mass equal to 16 gram. So, mole of molecules. Suppose 1 mole of oxygen contains 6.023 to 10 to the power 23 molecules, and their gram molecular weight is 32 grams. So 1 mole of, next example, 1 mole of water contains 6.023 into 10 to the power 23 molecules and have mass equal to 18 grams. Now 1 mole is also equal to occupy with the gaseous molecules. Then the 1 mole of any gaseous molecule occupies 22.4 liter at STP, and this volume is called the molar volume. So 12.4 liter volume of 1 mole is called the molar volume. So what is the molar volume? The molar volume of a gas can be defined as the volume occupied by 1 mole of a gas at a standard temperature and pressure. So at STP, 1 mole of a gas occupy what amount of the volume? That volume is called the molar volume, and that value and their value is 22.4 liter. So 1 mole of, suppose 1 mole of hydrogen, 1 mole of H2 equal to 22.4 liter of H2 gas occupy. 1 mole of O2 molecules occupy 22.4 liter of H2 O2 molecules in their gaseous form. So this is all about the mole concepts. Okay.